Can you see?
I can't. So maybe someone can help pick out people in the audience because
Hi
I
there.
can't actually see with the bright lights.
I have a question about the meteoritics. You mentioned that the smell of sulfur was reintroduced by witness testimony after having been discounted. Is there an explanation for that? And do you think it's possible maybe people are actually smelling ozone?
That's interesting. I'm not sure. So I've smelled ozone before. I know what sulfur smells like. And to me, they're different. But it is possible that that has something to do with it. On the other hand, I'm not sure that I was completely clear because there was an association in people's minds between fire and brimstone. At a certain point, that fell away. The brimstone kind of falls away. And then brimstone isn't showing up in the eyewitness accounts, is the idea. And so the thinking was that that was basically a kind of a feature of the ambient culture. That association is gone, and so people are no longer reporting the brimstone. But then it comes back in that spectacular event in 2013. So that's how that played out.
Thank you both for being here. There was recently an interview with Mark Andreessen, successful venture capital investor, where he had met with the administration and they had communicated to him that certain advanced scientific concepts in physics had been classified early in I believe it was the 40s or the 50s. I'm not sure if you've seen this interview that he gave. I'm curious if you have, and if so, what was your reaction to hearing that something fundamental physics could be taken out of academia and put in a box and not allowed out there for public research?
Well, I didn't. I heard about the interview. I didn't see it, and I'm not exactly sure how you classify ideas. You can have groups that work for you that come up with ideas and you don't share them with anybody, so in that sense it would be classified. But I mean, there are areas of physics that we don't really, we're encouraged not to study, basically. So one that's applicable to UAPs is anti-gravity. Nobody studies anti-gravity. You just don't do it. And is it because it's been classified and cordoned off? Not exactly. I mean, I was never told this. Nobody's ever told anybody I know this. But it's just something you don't study. And so it seems that with a lot of these things that have been, it's kind of like the reality of UFOs. You know, you don't have to cover up UFOs at all. You just have to make fun of it. And nobody wants to look at it. And the same thing with anti-gravity. You joke about, oh, he's studying anti-gravity, whatever. Yeah, in his garage, of course. Yes, I mean, you hear that all the time. And so nobody studies anti-gravity. Nobody believes UFOs are real, and that's easy to keep classified, easy to cover up.
All right, thank you both, Wesley and Kevin. That was great information. I loved it. I'm getting more out of the science than the impossible stuff. So one question for Kevin I have is, do you think that do you have a theory, or have you heard of theories in the overall academia part of physics of maybe some of these things are like emergent behaviors out of the intersectional crossing of like systems within physics itself? So we talk about like quantum field theory and relativistic physics, but those might be two parts of the same thing, and they probably are. But like, have you heard of like any concepts like that? I think there's like the Hildebrand brain and all these things. So maybe do you have any theories on like the conscious and like synchronicities and all that? Maybe those are emergent behaviors of these systems interacting, and then something comes out of them.
I mean, there's some situations where we have recognized, where emergent behavior has been recognized and studied, and there's usually suggestions that some of this, for lack of a better phrase, weird stuff, is usually described as emergent properties or quantum mechanics. And those are the two go-to science-sounding explanations, but I think that's what they are. They're science-sounding explanations. They're not actually scientific explanations at this point.
Yeah, okay, sorry. I'll try to keep it short because we talk all the time. But Wes, first, I had 2 questions for you. Von Fraunhofer, the spectra. What was the anomaly, if you could explain that? And I like your contrast between deliberate observation, which revealed an anomaly, but again, with respect to what? Was it determined to be an anomaly? And then you had, the contrast with the information coming from outside of the sanctioned observational context of something. This is very interesting. And then the transition to get that to be accepted, right, by the scientific community, and the process by which those external observations were internalized to the science. That's a very interesting issue, if you can comment on that. And then second part of the question, so Chladni, to what extent before there was a framework to understand the significance of his analysis of the eyewitness testimony, to what extent did that actually, was that constitutive of the formation of the science itself? Or was the science coming later and it was only retrospectively kind of recognized? And then Kevin, I had a question for you.
Well, he did have a concept of frictional heating, so that was already in place, but they at the time thought that probably combustion was involved, so they didn't understand about shock heating, so air being compressed and heated up so much that it becomes incandescent. So there was not. So there were some physical concepts in place that he could use, and of course there was also Immanuel Kant's nebular hypothesis, and I'm not sure that he cited it, but that would have been mid-18th century, so it would have been in the air, and so it's not like it came out of nowhere in that sense, right? The interplanetary hypothesis for the origin of meteorites. And then your first question, which I've already lost track of mostly, unfortunately, but the 2 anomalies that I pointed out were there's the black body spectrum, and so there's the ultraviolet catastrophe at the end of the 19th century, basically understanding why it looks the way that it does is a problem that leads in part to the development of quantum mechanics. And then the Fraunhofer lines, that's what it was. Okay, so those were the dark absorption lines.
How was that an anomaly?
And then and then you have later on in the century, Kirchhoff and Bunsen doing emission spectroscopy. And so you have those emission lines showing up, and nobody knows why you have discrete emission lines and absorption lines. So those correspond to electronic transitions. And that isn't understood until Niels Bohr proposes his model of the hydrogen atom.
So was it an anomaly or just a curiosity?
That's a really good question. So it was certainly unexpected with respect to the background.
Yeah.
But it was, there are things, kind of like curiosities. Like this is just something that we can't explain. It doesn't fit anywhere. It's kind of a misfit in a way. Yeah. So maybe it's a misfit phenomenon. You can think of it that way. But then you also had a question about eyewitnesses and so on. Okay, we'll talk about that later, except that there was something I wanted to say at the end of my talk, which I got off the stage too hastily, and I just wanted to...
The whole thing in UAP.
Right,
science,
right.
The evidentiary
Yeah.
significance of eyewitness testimony.
Right.
The Chladni study
was all about that. And so what I wanted to say was that eyewitness testimony in the physical sciences, it's not considered demonstrative of anything, right? That's usually the case. And it's not used, as I was saying, except in the special circumstance of this impact crater that formed in 2007. There are very few examples. But eyewitness testimony can and should be used to motivate rigorous scientific investigation. So this happens all the time in medicine. So people can notice, doctors, physicians can notice that there's something going around, there's something happening to people, and notice these correlations, and write it up even. And that's, again, not dispositive of anything, but then it can be used to motivate a systematic, rigorous experimental design. That's the way we ought to think about it. Don't push these things away or ignore them. Just think, okay, well, that's interesting. Maybe let's design an experiment to investigate. It's that simple. That's the only claim I want to make about UFOs today, and that's, let's study it scientifically, and that's what we're doing.
Okay, thank you. Thank you, Wes. Thank you, Kevin. We're going to shut it down there.